Have you ever found yourself, just tapping your foot, waiting for an app to load? Or maybe picture this. Every single time you needed a taxi, they had to build a brand new car just for you. Seems ridiculous, right?
Hmm.
But that kind of delay, that waste, it's actually something developers fight against all the time. So today, we're doing a deep dive into something that works behind the scenes, something that makes a lot of the apps you use super fast and really reliable. Connection pooling. And we're going to focus specifically on one really popular tool, especially in the Java world, called HikariCP.
Yeah, and the material we've looked at for this, it gives a really fantastic guide. It breaks down how this tech works, why it's such a big deal for solving certain problems, and crucially, why it's maybe more important than ever now in 2025. So our plan is to pull out those key ideas, distill them down so you can really get a quick handle on the impact it has.
Okay, let's unpack that. Connection
Yeah.
pooling. If you've ever worked with databases, connections are fundamental. But what exactly is pooling? The source material had some good analogies.
Right, think about a busy library. Instead of building a whole new entrance for every single person wanting a book, you should have a few really good entrances that stay open. People come and go using the same pathways. Connection pooling is basically that. You set up a bunch of database connections beforehand, keep them open, and then your application just reuses them whenever it needs to talk to the database. No constant opening and closing.
Ah, okay. So it's all about cutting out that setup time, that overhead. Makes sense. And where does HikariCP fit into this picture? What makes it special?
Well, HikariCP and Hikari means light in Japanese, which is fitting. It's a really, really popular connection pooling library. You see it everywhere in Java apps, especially with Spring Boot. Its big draw is that it's incredibly lightweight and super fast. Performance is its main game. You could maybe picture it as the most efficient dispatcher for your app's database requests. It makes sure every request gets an open connection quickly, whether that's to MySQL, Postgres, whatever database you're using. It's like having that shared fleet of taxis always warmed up and ready. And the neat thing is how it bundles its features. You get the reusability, obviously, keeping connections ready. That directly leads to massive efficiency gains because you skip the slow setup, which then lets you achieve scalability, handling tons of users with fewer connections. And it adds a layer of reliability by managing the health of those connections. Plus, the integration with Spring Boot is just seamless, makes life easier for developers.
Okay, so that's the what and the why. But how does it actually work? Under the hood, how does HikariCP manage this pool of connections to get those performance benefits?
Right. It follows a pretty logical 5-step process, but it's highly optimized. So first, when your Spring Boot app starts up, HikariCP kicks off and creates the pool. It sets up a specific number of database connections based on your configuration, things like minimum middle, maximum pool size. Think of it like opening a set number of checkout lanes at a supermarket before the rush.
Got it. Step 1, prepare the connections.
Exactly. Then step 2, when your application actually needs the database, maybe fetch user info, save an order, it doesn't create a new connection. It asks HikariCP to borrow a connection from that existing pool.
So it grabs one that's already waiting.
Precisely. Step 3 is simple. The application uses the connection to do whatever it needs to do with the database. Query data, update records, whatever.
Standard database interaction.
Yep. And then step 4, this is key. Once the task is done, the connection is immediately returned to the pool. It's not closed, just put back, marked as available for the next request, like that taxi going back to the depot.
Ready for the next fare.
And finally, step 5, which is super important for stability. HikariCP constantly manages the pool. It's not static. It actively checks if connections are still healthy, maybe using a validation query. It'll close connections that have been idle too long, handle timeouts gracefully, and even create new connections if demand spikes up to that maximum pool size limit. It sort of self-regulates.
That makes sense. It's actively keeping things healthy. The source material had a good practical example, right? Like an e-commerce site using Spring Boot. Say you have, 100 people browsing at the same time. How does HikariCP handle that if it only has, say, 10 connections in its pool?
Yeah, that's where the magic really happens. Instead of those 100 users trying to open 100 separate connections, which would probably crash the database.
Right, hitting the limit.
Exactly. They all share that pool of 10. When user A needs data, they borrow connection 1, use it real quick, put it back. Then user B might grab connection 1 or maybe connection 7. Because these database operations are usually very fast, measured in milliseconds, that borrowing and returning happens incredibly rapidly. So those 10 connections can actually serve hundreds, maybe thousands of requests per second. All 100 users get a snappy experience, and the database isn't overwhelmed. It's really efficient resource sharing, multiplexing.
Okay, that paints a clear picture.
Oh.
So zooming out again, what was life like before this? What were the big pain points developers dealt with without good connection pooling? And how did HikariCP basically write in to fix them?
Oh, it was rough. Before reliable pooling became the norm, you had some major issues. The most obvious one was just slow performance. Creating a new database connection for every single request takes time, network stuff, authentication, allocating resources. Milliseconds, sure, but they add up fast under load. Your app just felt sluggish. Imagine waiting seconds for a product page.
Yeah, nobody wants that.
Nobody. And that constant creation and destruction led to resource overload. It hammered the CPU and memory, both on the app server and the database server, costly and unstable.
Okay, what else?
Well, connection limits. Databases can only handle so many connections at once. Apps without pooling could hit that limit super easily, leading to errors, downtime. Very frustrating.
I can imagine.
Then there were connection leaks. This was nasty. If a developer forgot to close a connection or an error stopped it from closing properly, it would just stay open, hogging resources. Eventually, enough leaks could bring the whole database down.
Ouch. Like leaving library books scattered everywhere.
Exactly. All this meant real scalability issues. You just couldn't handle thousands of users reliably. And finally, it was just a complex setup. Managing connections manually, dealing with errors, trying to reuse them safely. It was a huge error-prone headache for development teams.
Wow. Okay. That sounds like a minefield.
Yeah.
So let's connect the dots. How does HikariTP specifically tackle each one of those problems you just laid out?
It addresses them pretty directly. First, boosts performance. By reusing connections, it eliminates that setup delay. That's the core speed benefit. Simple as that.
Got it. Performance boost.
Second, reduces resource usage. Less creating and destroying connections means less strain on CPU and memory on both ends. More efficient, more stable, cheaper to run.
Makes sense. Fewer resources needed.
Third, manages connection limits. You set a maximum pool size in HikariCP so it acts like a gatekeeper, preventing your app from flooding the database with too many requests at once.
Protects the database.
Right. Fourth, prevents leaks. This is a big one. HikariCP is designed to be robust. It automatically detects and closes connections that are idle too long or seem broken. It cleans up after itself, even if the application code has minor issues.
So it adds a safety net.
Definitely. And all this together enables scalability. Because it manages resources so well, your application can handle way more users and requests smoothly. And finally, for developers, it simplifies development. Especially with Spring Boot, adding HikariCP is often just a matter of configuration. It handles the complex plumbing, letting developers focus on the actual application features.
Okay, it's pretty clear why pooling is good, why HikariCP is good. But the research we looked at really hammered home why it's especially critical right now in 2025. You might think, hey, cloud databases are smart. Maybe they handle this. Is that true? Or is something like HikariCP still just as vital, maybe even more so?
That's a really important point. You might think the cloud abstracts everything away, but actually the need for efficient pooling like HikariCP provides has arguably increased. Why? Well, first, just the sheer explosion of data and users. Modern apps handle mind-boggling amounts of data, millions of users. Think social media, e-commerce during sales. Efficient database access is just table stakes now. HikariCP is key to managing that load.
Okay, scale's one factor.
Another big one is the trend towards cloud and microservices. Apps are broken down into smaller services, often running in the cloud. Each microservice might need its own database connections. Without pooling, they could easily overwhelm a shared database. HikariCP helps each service play nice.
Right, coordinating all those little pieces.
And then there's user expectations for speed. We're all impatient now, right? A tiny delay, even just a few hundred milliseconds, can mean losing a customer. HikariCP helps deliver that instant response users expect.
Every millisecond counts.
It really does. Plus, cost efficiency in the cloud. Cloud providers often charge based on usage, CPU, network, database time. Optimizing connections with HikariCP directly cuts down that usage, which means lower cloud bills. Crucial for startups especially.
Good point. Saves money.
And don't forget reliability and stability. For critical systems banking, healthcare, you absolutely cannot have connection issues bringing things down. HikariCP provides that robustness. Finally, there's developer productivity and the job market. Using standard, efficient tools like HikariCP makes developers faster, and knowing how to configure and tune it is actually a valuable skill.
That's not just abstract concepts either. The sources pointed to some big names using this kind of tech, right?
Oh, absolutely. Think about Amazon, especially during huge sales events. Their systems, many built with Java and Spring Boot, rely heavily on connection pooling like HikariCP to handle millions of product searches, inventory checks, orders per minute. It has to be fast and reliable.
Makes sense for that scale.
Or Netflix, delivering smooth streaming, fetching your watch history, recommendations that all involves rapid database access for millions of users simultaneously. Connection pooling is essential. Think about banks. When you use your online banking app, transactions need to be processed instantly and securely. HikariCP helps ensure that backend database performance. And even smaller startups, maybe a SaaS company that's growing fast. Using HikariCP lets them scale their user base efficiently without having to immediately throw tons of money at bigger database servers. It helps them manage growth smartly.
Okay, so it's clearly powerful stuff. Now, for you listening, maybe you're already familiar with Spring Boot, databases. This might make you want to dig deeper, really get hands-on with optimizing this. The material suggests that HikariCP is actually pretty approachable to really get good at, beyond just using the defaults. How would someone who knows the basics start exploring that next level?
Yeah, that's a great place to be. If you're already using Spring Boot and HikariCP, the next step is moving from just using it to really understanding and tuning it. First thing I'd say is dive into the official HikariCP documentation. Seriously, read it. Understand what parameters like maximum pool size, minimum middle, connection timeout, idle timeout actually do. They're not just settings, they're levers you can pull to tune performance for your specific workload.
So really learn the configuration options.
Exactly. Don't just copy-paste defaults. Then, experiment with connection validation. Look into connection test query or the newer keep alive time. How does HikariCP make sure a connection is still good before handing it out? Understanding that is key for reliability.
Okay, validation strategies. Makes sense.
Next, try setting up a benchmarking environment. This is huge. Use a tool like JMeter, maybe Gatling, to hammer a simple Spring Boot app with simulated traffic. Then, tweak the HikariCP settings and watch what happens to response times, error rates, CPU usage. There's no substitute for seeing the impact of your changes under load.
Get hands-on, measure the results.
Definitely. And finally, explore monitoring integrations. HikariCP plays really nicely with tools like Micrometer, which Spring Boot uses for metrics. You can expose detailed pool stats, active connections, idle connections, wait times, and view them in dashboards like Prometheus and Grafana. Seeing those metrics in real time is incredibly powerful for diagnosing issues and optimizing performance intelligently. And, don't hesitate to look at Stack Overflow discussions or even browse the source code for really tricky situations. So, yeah, this deep dive really shows that connection pooling, especially with a tool like HikariCP, isn't just some minor optimization. It's fundamental. It makes Spring Boot apps faster, way more scalable, much more reliable. It's a really elegant solution to some persistent database headaches. And honestly, it's an essential piece of the puzzle in today's data-heavy cloud-first world.
So what's the takeaway for you? Maybe consider this. The next time you use an app that just feels instantly responsive, lightning fast, take a second. Think about those invisible connections being managed, pooled, reused behind the curtain. This whole idea of pooling resources for efficiency isn't just for software databases, is it? Where else do you see it? Think about logistics, maybe shared transportation, even how energy grids work, or perhaps just organizing your own time efficiently. Where else are these principles of reuse and smart management making things work better than you might realize? Thanks for diving deep with us today. We hope this look into HikariCP has sparked some new ideas for you.